Greetings, ladies and gentlemen. Today, we're going to present our project named Real-Time Victim Detection and Toxic Gas Monitoring using Unmanned Aerial Vehicle. Firstly, let's begin with our introduction. There are various challenges to rescuing a victim out of a place that is hard to access. For instance, narrow passages, a limited sight of vision, etc. But the one that our research was really focusing on is toxic gases and particulate matter pathogens. The reason is because toxic gases were very hazardous for the victim's life. If the rescue team weren't able to make it on time, the consequences of inhaling too much toxic gas, such as carbon monoxide gas, which has a much stronger affinity compared to oxygen, results in a strong foundation of hemoglobin and carbon monoxide, which will make our body experience the lack of oxygen. In addition, a particulate matter called PM2.5 was also another issue for the rescuer. PM2.5 can irritate the respiratory system, resulting in serious symptoms as coughing and dyspnea. In light of this, all of this dangerous material will weaken their bodies until they finally collapse in the presence of toxic gas, resulting in additional long-term health problems. Furthermore, the rescuer might breathe in toxic gas. Both the savior and the victims suffered as a result. Having said that, our concept is probably going to remove the chance that the rescuer would inhale the toxic vapors while looking for the victims by their own. Utilizing an autonomous drone fitted with an air quality sensor and a thermal camera to look for the victims and evaluate the air quality before sending out a responder.
For the thermal image camera, we use the MLX90640 in our project. The reason we choose this sensor is because it's low cost at around $80 and the compatibility with Raspberry Pi and also customizability with Python script. The lightweight and small size, which is great options for using with our drone. The key features are the resolution of 32 times 24 pixels and temperature range of -40 degrees to 300 degrees Celsius. And we also use air sensors that can detect small particles like PM2.5 and PM10, some toxic gases such as carbon dioxide and formaldehyde, along with the humidity and temperature sensors to acquire the environmental data in the rescue sites. Overall payload is about 200 grams, which gives us about 15 minutes of flight time. In software development, we use Python script to export thermal camera input. And we also use Node-RED for some data visualization and laptop screen for thermal video. For the setting up the system, first we install the Raspberry Pi operating system and then we test it with our drone battery. And then we connect our sensors, which is thermal camera and air quality sensors, to Raspberry Pi via the RS485. And then we develop the Python script using to capturing temperature and other data, and then install necessary software for the data collection. And last, we install all the components on our drone system.
Turning to results and discussions based on our experiment, at the 10 meter, the camera can detect human-sized objects but with limited details. However, at the closer distance, it can distinguish smaller features like limbs or fingers. To detect a human from 10 meters above, the resolution is sufficient to identify his signatures but won't provide any detailed body cultures. As you can see, the low-cost air quality sensors used in this work show similar results as the standard measurement tool, indicating of its high efficiency sensors. Here is real-time monitoring results that show you the actual image compared between the real-time thermal image as well as real-time air quality monitoring systems. Finishing the monograph, the integrations of thermal imaging and air quality sensors on UAV platform provides effective tools for search and rescue missions in hazardous environments. Moreover, the low-cost sensors used in this work show similar results as the standard measurement tool, indicating of its high-efficiency sensors. Additionally, this UAV-based system significantly reduces operational costs, including manpower, fuels, and equipment maintained. To be more specific, the modular design allows for easy improvement and component repairments. Thank you for listening to our presentations.